Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we talked about various components of time series. We were discussing how to find out trend by various methods and how to find out a seasonal index by eliminating the trend values. In continuation with the topic, the objective of this session is to study about index numbers in detail. That is, what is meant by index number, what are its uses, and what are its limitations, what are the various methods to calculate index number likewise. First of all, an index number may be described as a specialized average designed to measure the change in the phenomenon with respect to time, geographic location or other characteristics such as income, etc. Thus, when we say that index number of wholesale price of a commodity is 125 for the period January 2010 compared to January 2009, it means there is a net increase in the price of wholesale commodity to the extent of 25%. That is, for the year 2009, we should keep the base price as 100, and when we see the wholesale price is 125, we see 25, whatever the unit you are using, rupees or dollars or whatever it may be you are using, 25% has been increased. Okay. So, that is what is about discussion about index number. So, index numbers are actually specialized averages. Index number measure the change in the level of a phenomenon. Index numbers measures the effect of changes over a period of time. Basically, what is the uses of index numbers? Index numbers are indispensable tools of economic and business analysis. Their significance can be best appreciated by the following points. They help in framing suitable policies. For example, for deciding the increase in dearness allowance of the employees, the employer has to depend primarily upon the cost of living index. This cost of living index is otherwise called as consumer price index number. If wages and salaries are not adjusted in accordance with the cost of living, very often it leads to strikes, lockouts, which in turn cause considerable waste of resources. Because whenever we consider the wage increase or salary increase, we have to look into the price of the commodities increase also. If not, the employers will go for strike and employees will go for lockouts, which in turn causes considerable waste of resources. The next use for index numbers is they reveal trends and tendencies. Trend is just we have calculated. Since index numbers are most widely used for measuring changes over a period of time, the time series so formed enables us to study the general trend of the phenomenon under study. For example, by examining index number of imports of India for the last 8 to 10 years, we can say that our imports are showing an upward tendency, that is, they are rising year after year. So, by examining the trends of the phenomenon under study, we can draw a very important conclusion, that is how much change is taking place due to effect of seasonality, cyclical forces and irregular forces, etc. The next use is index numbers are also very useful in deflating. That is, index numbers are used to adjust the original data for price changes or to adjust wage for cost of living changes and thus transform nominal wages into real wages. After studying about uses of index numbers, next we will study about the various types of index numbers. Index numbers may be classified in terms of what they measure. In economics and business, the classifications are the four price index numbers, quantity index numbers, value index numbers and special purpose index numbers. Actually, special purpose index numbers constructed for a single commodity, then it is called simple index number. If it is constructed for a group of commodities, then it is called composite index numbers. Basically, when you want to construct an index number, what are the problems faced in the construction of index numbers? This may be also termed as limitations of index numbers. The purpose of the index is one of the problem, availability and comparability of data, selection of base period. The base period should be normal one, the base period should not be too distant in the past, and fixed base or chain base should be adopted. Next, selection of number of items, price quotations, choice of an average, because index numbers can be calculated using arithmetic mean as well as using geometric mean also. When the index number has to be calculated by geometric mean, arithmetic mean method does not work out. So, we have to choose an average, that is very important, and selection of appropriate weights, selection of an appropriate formula. Okay. These are the limitations of index number. Next, methods of constructing index numbers. Broadly speaking, they can be grouped into two heads: unweighted index numbers and weighted index numbers. In the unweighted index numbers, weights are not expressively assigned, whereas in the weighted index, weights are assigned to the various items. Each of these types may be further be divided into two heads: simple aggregative and simple average of price relatives. Similarly, weighted method also can be termed into two methods, that is weighted aggregative and weighted average of price relatives. So, these are the various methods of index numbers. Basically, index numbers are of four types: price index, quantity index, value index and then special purpose index. For the calculation of these index numbers, the methods are unweighted method and weighted method. In unweighted method, there are two methods: simple aggregative and simple average of price relatives, that is link relative method. In the weighted method, weighted aggregative and weighted average of price relatives are used. Starting from the first unweighted index numbers, a simple aggregative method. Now, how the method is used? The simplest method. When this method is used to construct a price index, the total of current year prices for the various commodities in question is divided by the total of base year prices. Current year prices are denoted as P1 and the base year prices are denoted as P0. Similarly, quantity for the current year is written as Q1 and quantity for the base year is written as Q0. So, divided by the total base year price, the quotient answer we are getting, that has to be multiplied with 100 for representing it at percentage. Symbolically, where total of current year prices for various commodities and total of base year prices for various commodities. First of all, add current year prices for various commodities, that is you have to obtain summation P1, add the base year prices for the same commodities, that is obtain summation P0, divide and multiply the quotient by 100. First of all, summation P1 by summation P0 into 100, divide, that is divide in the sense summation P1 by summation P0 and then multiply the quotient by 100, that is your index number. We shall see this with an example. From the following data, construct an index number for the year 2010 taking 2009 as the base year. Whatever the data given, base year has to be specified. If not, the least year is taken as the base year and the last year is taken as the last year, in the sense the current year is taken as the P1 values or Q1 values. Now see, the commodity and their units are given. For the butter, the price in the year 2009 is 110 and in the price in the year 2010 is 120. So, there is a 10 rupees increase, and for the cheese 75 rupees and 80 rupees. Likewise, we can see the commodities and their prices in the year 2009 and the year 2010. We shall construct the price index for this problem. Okay. First of all, take the tabular column and take its total. Total of the 6 commodities price is taken as P naught, as I told you. P naught starting from 110 to 850 is 1075, and similarly starting from 120 to 860 for the year 2010, which is P1 values. So, summation P naught is 1075 and summation P1 is equal to 1102. This means as compared to 2009, in 2010 there is a net increase in price of commodities to the extent of 2.51. Now, the price index is calculated using the formula. Price index is equal to P01. P01 is 0 is for the base year and 1 is for the current year, is summation P1 by summation P naught into 100. Summation P1 value is 1102 and summation P naught is 1075 into 100. See, summation P1 is 1102 and summation P naught is 1075 into 100, which is equal to 102.51. So, what do we say? The conclusion is compared to 2009, in 2010 there is a net increase in price of commodities included in the index to the extent of 2.51. This 2.51 is the increase from 100. So, 2.51 percentage. There is an increase in each item. Butter price is increased from 110 to 120, which means there is an increase of 2.51 percentage price increase in the butter from 2009 to 2010. Likewise, only we have to interpret the given data. Next, simple average of relatives method. First of all, you have to calculate relatives, then take the average, then we will get the index number. When this method is used to construct a price index, price relatives, when we are talking about the prices, the index number thus obtained will be called as price index numbers. When this method is used to construct a price index, price relatives are obtained for various items included in index, and then an average of these relatives is obtained using any one of the measures of central tendency, that is arithmetic mean or median or mode or geometric mean or harmonic mean. Use of this mean is very important, and when arithmetic mean is used for averaging the relatives, the formula for computing the index is index number using AM, arithmetic mean is P01 is equal to summation P1 by summation P naught into 100 by N, where N refers to the number of items whose that is number of commodities whose price relatives are thus averaged. Although any measure of central tendency can be used to obtain overall index, price relatives are generally averaged either by geometric or arithmetic mean. When geometric mean is used, the formula for obtaining the index becomes log of P01 is equal to summation log of P1 by P naught into 100, the whole thing by N. Okay. When you take this particular value as capital P, then we get summation log P by capital N, where P is equal to P1 by P naught into 100. We shall see how the price index numbers are calculated by simple average of price relatives based on arithmetic mean method and based on geometric mean method. So, this is index numbers by geometric mean method. Again the same problem you can take into account, commodity and unit butter is 2910 and 2010 it is 120. Likewise the same values are given. We shall see how the price index are calculated using a simple average of price relatives. This is P1 by P0 into 100. The 109 is calculated as 120 by 1110 into 100 is equal to 109, and similarly 80 by 75 into 100, P1 by P0 into 100 is equal to 106.67. Likewise the values are calculated, then their summation, when you take this summation values, summation of P1 by P0 into 100, the whole thing starting from 109 to 1.18, the values are added and this total comes to be equal to 628.05, and the price index or P01 is summation P1 by P0 into 100 whole thing by n. N is the number of items. How many items are given? 6. So, n is equal to 6 and this value is 628.05 divided by 6 and the value comes to be equal to 104.67. Okay. Similarly, this is by geometric mean method. For geometric mean we have to take a capital P. Capital P is equal to price relatives, the values are just written as it is and the price relatives are capital P is equal to P1 by P0 into 100. Again it is 109 which is nothing but 120 by 1110 into 100 is equal to 109, and these values are calculated, each one is taken with log, that is log of 109, okay, and it is taken to the base 10. LOG values, log 109 is 2.0378, likewise all the values are taken into account. This summation log P is equal to 12.1166. Okay. How the price index are calculated using geometric mean is P01 is equal to summation of log capital P by capital N. Summation of log capital P is 12.1166 by number of items is 6. Whatever the values you are having, that is taken as log, right, is actually log of P01, which is 2.0194. So, if you want P01, take anti-log of 2.0194 and this comes to be equal to 104.57. Small change only between arithmetic mean method and geometric mean method. Okay. We talked about unweighted index numbers and we have also seen methods to calculate unweighted index numbers by the method of simple aggregative index numbers and a simple average of relatives method. So, next is in continuation with the classification of index numbers, next one is weighted index number. Weighted index numbers are of two types, weighted aggregative index numbers and weighted average of relative index numbers. Okay. Weighted aggregative index numbers, there are various methods of assigning weights and consequently a large number of formulae for constructing index numbers have been devised, of which some of the more important ones are Laspeyres method, Paasche method, Dorbish and Bowley's method, Fisher's ideal method, because among all the methods this is the ideal one, therefore it is called Fisher's ideal method, Marshall Edgeworth method and Kelly's method. We shall discuss these methods one by one, all are related to each other. First of all, Laspeyres method. In this method the base year quantities are taken as weights. The formula for constructing index is P01 is equal to summation P1 Q naught by summation P naught Q naught into 100. Okay. Multiply the base year of various commodities with base year weights and obtain summation P1 Q naught. Next, multiply the base year prices of various commodities with base year weight and obtain summation P naught Q naught. Divide summation P1 Q naught by summation P naught Q naught and multiply the quotient by 100. This gives the price index. Next method is Paasche method. In this method, current year quantities are taken as weights. Just compare, in Paasche method, the base year quantities are taken as weight, whereas in Paasche method, current year quantities are taken as weights. The formula for constructing index numbers is P01 is equal to summation P1 Q1 by summation P0 Q1 into 100. Okay. Multiply the current year prices of various commodities with the current year weights and obtain summation P1 Q1. Multiply the base year prices of various commodities with the current year weights and obtain summation P0 Q1. Divide summation P1 Q1 by summation P0 Q1 and multiply the quotient by 100. In general, this formula answers the question, what would be the value of the given period list of goods when valued at base period price. Next, Darbish and Bowley's have suggested simple arithmetic mean of two indices, that is Paasche method and Paasche method mentioned above, so as to take into account the influence of both the periods, current as well as base period. So, the formula for constructing the index by Darbish and Bowley's method is P01 is equal to L plus P by 2 is equal to summation P1 Q naught by summation P0 Q naught plus summation P1 Q1 by summation P0 Q1 into 100 whole thing by 2. This formula summation P1 Q naught by summation P0 Q naught into 100 is the price index by Paasche method, and summation P1 Q1 by summation P0 Q1 into 100 is the formula by Paasche method. So, both the formula is added and then divided by 2. So, Darbish and Bowley has calculated price index by taking the average of these two methods. Next is Fisher's ideal method. As Professor Fisher has given a number formulae for constructing index number, and of these he calls as one of the ideal index. So, the Fisher index number is given by the formula P01 is equal to square root of summation P1 Q naught by summation P0 Q naught into summation P1 Q1 by summation P0 Q1 into 100. It is actually saying as root of L into P. Paasche method index number into Paasche's index number and then its square root, or P01 is equal to square root of L into P. It shall be clear from the above formula that Fisher's ideal index number is the geometric mean of the Paasche and Paasche's indices. Marshall's Edgeworth method. In this method also both the current years as well as base years prices and quantities are considered. The formula for constructing the index is P01 is equal to summation P1 Q naught plus P1 Q1 divided by summation P0 Q naught plus summation P0 Q1 into 100. This can be written as a separate summations, summation P1 Q naught plus summation P1 Q1 by summation P0 Q naught plus summation P0 Q1 into 100. This is the price index using Marshall's Edgeworth method. Next, Kelly's method. Kelly has suggested the following formula for constructing index number. So, P01 is equal to summation P1 Q by summation P naught Q into 100, where Q is equal to Q naught plus Q1 by 2. In this session, we were talking about a new topic called index numbers. What is meant by index number was discussed, and uses and limitations of index number was discussed. Various types of index numbers like price index number, value index number, quantity index number, special purpose index numbers were discussed. Methods to calculate weighted and unweighted index numbers were also discussed, and then a problem was worked out in calculating unweighted index numbers. Various methods of calculating weighted index numbers was also discussed. Based on the discussion in this session, the following questions may be posed. What is meant by index number? Mention the uses and limitations of index numbers. Explain the various methods to calculate price index numbers, and explain the various methods to calculate quantity index numbers. Thank you.